And analyze Lawrence and Cousin for the cell breakage. So you can consult this article. This has been recently published in 2016. You can note down the reference, or I can send a copy to Professor, so he will send it back. So you'll find that how this question constitution, how the factors have been optimized to make the maximum amount of cell. And the rest of the part of this technique has not been published, so it will be published shortly, depending on how far my students are able to convince us that the technique works, and it works also at least at 2 scale, not at the milliliter scales, but also at the liters. So you'll see that all my students are Indian group, big Indian group, very hardworking group. Shravan is the PhD student working on this. Jyoti, she was my research associate, and she's not working anymore. And Rajvinder, she has just recently joined me. Mr. Kurti Raja has finished his PhD, so he's going to defend his thesis sometimes in the first week. So it was a joint effort. The main author is Mr. Shravan. Now it's open to the question, and you can ask the question in Hindi, English, Sanskrit, French, anything. I know very good Sanskrit.
You start question. Your experiences in your lab and what you are doing, and
so
also
after like you showed us, after concentrating the cellular concentration, you did the cell disruption using NNS. Then using petrodiesel, you extracted the lipid into petrodiesel. So 2 questions from this. First, that once you separated the petrodiesel, what did you do with the remaining cellular and mass and water? It's just another waste. Did you throw away?
Yes, it's a very good question, and we have recently applied for a project on that issue, but we haven't done anything so far. And in our cost estimation programs, we are taking it as a waste, as all the solids, whatever residue goes out, it goes to the landfill. But if we succeed in getting the project, we will estimate. So we have proposed to estimate the cell wall components. So there are lots of aroma compounds and the intracellular compounds also, because the yeast used to generate lipids in this case is a very good lipid and known to synthesize several aroma compounds. So we'll estimate that. And also the soluble protein we have to recover, as I said yesterday, from the Quaker case. So the company is there who can use, which buys the protein at a quite good value. So yeah, those are the things I plan. But at present, no, I have no data on that, and I have no research. I have no research student even working that. But very shortly, I'm recruiting a student, and I'm in the process of recruiting a student from any time now, or now we will start in January. So that would be one of the projects.
And the second one related to this, the petrodiesel containing the biodiesel, how did you estimate it to be 15%?
How did I, okay, very good. Very good question. You can do it in FKI. Yeah. Please. I think I'm not sure if you can do GC also, but certainly you can do
GCMS data that you have on petrochemical.
You also have the crude the petrodiesel
standard?
Yeah, okay. We run that along with the standard for bio.
They're very fine details.
Manish had some data related to that one. that you have gone for the petrol diesel, which is less.
The data is not, because when we use petrol diesel, like we don't have a column for that petrol diesel.
Oh, you mean
Pura
the
pack.
GC?
Yeah, GC.
Or you use
So
Pura pack?
it's a Pura pack column they required for the analysis.
Or you don't have Pura pack?
Yeah.
So certainly there must be some FTIR in the university.
Yeah.
We have to go and
For that now we required for the standard.
that's in case of petrol diesel, that's the best thing. I'm not sure about the fine details of the process, but if you write to me or you write directly to Sharon, then you need to. But because this work we recently started maybe 6 months back, and we are in full bloom to go because there is a financial stake in this process. But there are many questions to be answered. But this is not a problem. I mean, this solution exists. You read the complete protocols and everything, so I will write to you
You tell us about your the sludge, that how much fatty acids and how much fatty acids you are getting now.
Sir, we got basically on time secondary sludge, which is I have took from Basant Kunj as well as JNU STP, and what we are estimating around lipid content is it's not linear kind of thing, but it's 20%, sometimes 20%, 19% or 80%. So it's a range around 17 to 22% lipid content. And when we transesterified by using acid as a catalyst, the percentage conversion of transesterification efficiency when we with different concentration of H2SO4. So it's around 17 to 18%, sir.
17, only 17 to 18?
Yeah.
Really low.
No, it's by gravimetry. This is GC, fatty acid methyl ester content. But transesterification efficiency is around 91-92%.
Transesterification efficiency is
yeah.
So once you have transesterification efficiency, then you can remove those, because you have to remove those frames in that from the solution.
Yeah.
So it's the 17-18% what we're talking in this final solution.
Final solution.
That's good. So that's very good.
But-
Separate that, but I'm surprised that it is 20% we have the liquid plant and liquid content is 40%.
That's what I was surprised.
So,
So that's what I was. That's what I was surprised. So I did 3 and 4 times. The same process for it.
Yeah, that can lead to because I do not remember those last figures, and but the tends towards to be in the zone of economic feasibility of the process. In fact, I don't remember exactly, because as I told, this was the South Korean this last month.
Yeah. And one more thing I would like to share, sir, just because I did 3 kind of analytical technique like GCMS and FTIR and NMR. In all the technique, we didn't use a standard because we have a problem with such यहाँ पे जो advanced instrumentation facility है, because we are running lots of sample. So every time 2 to 5% contaminants is there, undesirable contaminants is there. When we use
those contaminants, they come from the column.
Maybe.
So they flush the column before you use.
Because lots of sample they were running.
No, that is internal problem.
Yeah.
I will discuss
That's
this
how
one.
that's what you can do. So that's what you have to do. Basically, you have to flush the column for a couple of hours to make sure that its column is clean. And then probably record the peak if there is no peak or something, or put a sample, known sample, and if you get the known peaks, that means column is flushed out.
Yeah.
The column is not flushed out.
So we also getting the range of biodiesel from C6 to C24, 25.
Most of more because this is all
But
kitchen
the
waste
majority
coming,
is hexadecanoic acid
cardinal
and
oil,
octadecanoic acid, like you
So
have
minimum
mentioned.
carbon is what?
C6 to C20.
C16.
C16.
The majority carbon is C16, C18.
Yeah.
That is monounsaturated
That
and
is okay.
saturated
Yeah.
carbon. So we are getting same profile like.
Yeah, you will get the same profile because the same factor.
Same thing.
Because the kitchen waste basically.
Yeah.
They emanate from the kitchen. And in the kitchen you use the same type of wall. I don't know
But
what.
surprisingly, what we did like when we use primary sludge, we know we are getting more fatty acid content, sir. And
In primary sludge, higher fatty acid.
Yeah,
but
we
free
know.
FFA.
Yeah, fatty acid.
Okay, you mean lipids.
Lipids.
Okay, so in primary sludge you have higher lipids than in secondary sludge.
Secondary
That's
sludge.
obvious.
That is obvious. That Professor Tyagi.
That's
But the free fatty acid content in more in primary sludge as compared to secondary sludge. Free fatty.
Okay, total lipids are also more than
Mm-hmm.
secondary.
Mhm.
FFA content is also more than the secondary.
Second.
Yeah, this is obvious. Because everything on all these oil slicks, oil particles, they stick to the solid particles. And they go with the primary sludge. So very less is left in the secondary, in the primary treated effluent. That's what is everywhere. It's the same story. It's the same story. And also in secondary treatment, some of these oil slicks and particles left, they can be consumed by the microbiota.
Microbes.
And also when you produce sludge, take the sludge and sterilize and then inoculate with microorganism, they will also degrade this. But it's quite high, I'm surprised. Because I never came across it.
Life is time.
Very good. अरे अरे दीजिए आपके पास तो प्रोजेक्ट है कर क्या रहे हैं?
I can tell you what it is. In Narmada hostel, there was a complaint that this Nali drainage was chocked. Okay, and then the engineering people went there in the winter time. And then they reported me that this drainage was full of, that
With oil.
Fat.
Because oil, okay, it's phases.
Can you believe it?
Solidified.
40 liters, 40 kg in that.
It was solidifying.
Solidified.
The pipeline.
It was chucked. And then because I was associate dean of student, they reported me that sir, this is because of that.
वो तो ऐसा था उसको
कौन सा है कहते हैं घी
घी
So they just discarded it. It's terrible. That's why a lot of problem was there at that time.
So they need to flush the hot water. Now that's something I'm noting down here at my guest house. Because when I go to take bath, so I feel very cold, the water is a little bit cold. But if I let the tap run for 5 minutes, then the hot water comes in. And then it's so comfortable to take the bath. So every day I leave the water run for 5 minutes. Okay. I don't know where, probably the pipeline is exposed somewhere, some outside, or probably it is exposed to some heating system. And then, okay. So anyway, so if that's a usual problem. If normally when the people have this used oil, they do not throw in the sewer line, because otherwise it will cause this problem. Just imagine if it happens in Delhi, what will we be doing in Quebec? It will immediately solidify so that because no temperature. So normally they collect it separately, and they dispose it separately also. If there is no taker for biodiesel production.
Collected separately, so
अरे ड्रम भर के रख लो। No, ड्रम भर के रख लिया, एक तरफ रखा हुआ है. That's what they basically not in your kitchen. Don't use in kitchen. Normally in kitchen, we throw, but that's very small quantity. And then we have the hot water top and the cold water tank. Just flush with the hot water, it goes out. Just run the hot water is at 70 degrees centigrade. If your heater, that water heating system is how do you say that, is new, and it will be around 50 degrees centigrade if your heating system is old. Because every household has that heating system with something like this height and something like this diameter. So every house in the basement, this unit is there, it is installed. And its lifetime is roughly 10 years. So, and there is a mark date on that you must replace by that date. So that it supplies the hot water in every home. Okay. It's automatically on all the time, around the clock, 365 days. Okay. And a safety charge. So this problem is there. But what I'm talking, the collecting separately, this oil is in the restaurants, because they are the people, like he's talking about mess of the hostel, because they make food in bulk. I don't know how many thousand students they must be making, so it's a big amount. But if they dump it into the sewer line, that's what will happen. But that's a very good source. You collect it and transfer straight by and see that. You can check paper chapo.
That's what we are
You
targeting
can make
JNU
paper
STP,
chapo.
sir.
Eh?
That's what we are targeting JNU STP.
Yeah.
It's
No, you can do,
good
but
fit
okay,
as
no,
well.
but okay, it's fine. I'm sorry, I put it in that way, that paper chapo. But you should not limit to that. You have to look for beyond that. Because what you know, like
It's
sludge,
better- it's
sludge,
better
but
to-
okay, I'm not sure the statistics of the sludge produced. Because that you have to see that how much sludge is produced, and it's so many people. Just imagine how many 50 million people in this city. How much of this sludge? I don't know where it goes. So just imagine if you collect all this sludge and extract this oil, how much oil? Oh, by the way, I had a figure. I don't know why I did not have this. I wanted to. Wait a minute, something. Okay. I don't know where this appeared, this slide. I just remember, no, I'm not on the right way. Where is that? I was going to this. Where is that slide? This is the right side. Ah, okay, so it is here for tomorrow. But anyway, as the time come, okay, you can see the magnitude, okay, the situation. Now this is a scenario of the Montreal city, which is the biggest city in Quebec province, and the population is approximately 3 million. People are living, and all the wastewater is collected in one wastewater treatment plant, and it generates about 260 tons of sludge per day. Okay. All this together, okay. And then you have in your this slide in your the write-up I sent to you. Okay. So it contains about 15% lipids. This lipid is also high because this is only the wastewater, the primary treated sludge. This wastewater treatment plant has no secondary unit. After the primary treatment, they discharge directly into the St. Lawrence River, and the COD is high, quite, but they are doing that. But now they are considering also to put up a secondary wastewater treatment plant. So the disposal cost for this sludge is something like $300 per ton. Okay, so that means lipids and fats which you can recover from this 260 tons per day. 15% is something like 39 tons per day. That 39 per day of the lipids and fats, if you convert it into biodiesel, you will have 35 tons of biodiesel per day. Per day, correct? And
they are already getting it.
sorry?
They are
Probable.
Probable.
It will be extra.
No, this is my estimates. They are not doing anything. Right now, no, they are not doing anything. This is just this is a forecast. Okay? So what I'm telling here to you that okay, it's a forecast, and then you calculate in Delhi what is happening. Okay. So, but because we are in touch with them, and our company is seriously thinking to do that, but all that depends on the cost estimation, right? So here is 43.7 10 to the power 3 liters per day of the biodiesel. That can derive 2,000 heavy trucks every day. 2,000 heavy trucks every day. Not the trucks like here in India, but they are much bigger trucks, and they're very sturdy also. They are not like the Lachar here, okay? Where it goes everything. And then sometimes there's a trail of those trucks. Okay, the two trucks okay are joined together, and then pulls them. So these are the heavy trucks. So GIAN is roughly 332,000 tons per year. Carbon credit $10 per credit. Let me see that. The current sludge disposal cost is something like $26 million per year. Correct? So if we have the biodiesel sale, is roughly here 15, okay, around this. Biodiesel sale is about 15 million, correct? Biodiesel GIG credit, roughly 3 million, okay? The total credits brings you 20 million, correct? And this is the residual sludge which will be left for the disposal, and which will cost you to dispose, 25 million. So basically, your net disposal cost goes from 27 million to roughly 3 million. That's what they say. And that's, imagine, if you take the Delhi sludge and okay, do some calculation like this and send to me. Who will send me? Who will do this job for me? Can anyone of you voting? Okay, Kushma will do that job for me. Okay. Make sure that I'm going to public. So I mean that. And when you have done this, then you have to see that how much will be costing to collect, how many wastewater treatment. Okay, fortunately in Montreal there's only one wastewater plant, so we can put up a unit there directly to pass this primary sludge through the collection, through the extraction unit. But in Delhi, so that you have to establish small unit to extract that water, and then probably sterify at one place. Like the company is going right now for the used oil, they have put the drums everywhere in every city, and they collect it and they bring it to their company, their factory, and then convert it into biodiesel and separate it and sell it. So you see, this is an example of that. Anyway, discuss the details because it's a little late tomorrow, so energy balance because I wasn't sure. So anyway, so that's what it is.
So there was a slide where you compared the lipid content in the different organisms, fishy, organometallics and all, in different sludge media and otherwise also.
Different type of sludge.
Yeah. So how did you measure the lipid content for fiscia, say in primary water sludge media?
This is the one?
Yes, sir. Wouldn't your estimation of lipid content in, say, primary waste sludge also include some lipid content from the sludge itself? Like you?
No.
No. How, so you separated the cells?
No, you know, whatever.
Yeah.
You grow your, you sterilize your sludge because you have to sterilize. You are
Right.
growing a pure microorganism, pure culture. So then you grow, and then take a sample, whatever the solids are there, and then put it in the bag. So it will contain your lipid bearing microbes as well as it will contain your inner molecule.
Right.
So you take the sample, you centrifuge now, you dry it with diamidization. So you powder, take the powder, extract the lipid, the solvent, chloroform methanol, standard analytical technique, and then pass through GC. And the standard, and then you will have your normal lipid. Or you evaporate the chloroform solution, and then you measure by gravity. But precautionary, you must go through GCMS to find out all this spectrum of fatty acids and the case of fame, convert it into fames, and then take that value as your lipid. Because otherwise, you know, in gravimetric analysis, chloroform can also solubilize something else. God knows. You have all this. Everything is there. Name everything is in sludge. Correct. So that's why, you know, though there was not much difference, but I was up to my students to check that, cross-check that okay, you're not making any error. And but you should also do, if you're doing this job, then you must do it at least one or twice to make sure that your estimations are correct.
Sir, do you have any chromatogram of GCMS right now?
यहाँ पर तो कोई नहीं है, लेकिन मैं मंगवा सकता हूँ. Write to my student. They will say.
Sludge, because
Where's that?
And did you see a difference in fame profile when you were growing this organism in pure synthetic media versus growing it in different sludge?
Yeah, we had. I had a. Should I not? I'm not sure. Yes. Go to that. Yes. What was this? So this was something I got it down from the pieces. So you see a minuscule primary. This is the one here. Yeah, basic medium. Yeah, but this is a free fatty acid. Unfortunately, yeah. No, the complete. No, I don't think so. There is no difference, certainly not. But let's see. When we have in the pure glycerol, if you want, produced from the glycerol, no sludge here. The same story, ojotropa on this side. But from the, oh my God, I don't think that we no. We did very few experiments. There's no point. Of course, you do synthetic medium, you can easily get for 50-60 grams solution.
No, sir, not amount wise, profile wise, qualitative, more or less.
The C16 to C18, C14, C18. Always same. Because synthesis of fatty acids is a characteristic of microbes.
Yes.
But having said that does not end the story, because certainly conditions exposed in external medium can change. Because microbes are, they respond to the external medium, yeah, their proportion may change, C14 to C18, but normally these are the only. There was one example where capnoic acid was very high, and that has some value, but I don't think so. Work is so much, work is so much that. Sometimes it becomes for me even to remember and tell students what next.
So, Muni, do you have any question? What do you want to do?
हिंदी में पूछे कहाँ गए रामलाल जी? हाँ रामलाल जी नहीं है?
रामलाल।
अरे पीछे क्या बैठे हो? ये पीछे ये बड़े मतलब क्या चक्कर की बात है भाई? अरे मदन लाल जी। Oh, I'm very sorry मदन लाल जी। चलिए पूछिए मदन लाल जी। इनका क्वेश्चन जरूर पूछना मुझे होता है। अब ये सोच रहे हैं, चलिए तब तक और बोलेंगे, आप नहीं पूछेगा। आप सोच लीजिए अपना अच्छी तरह, सोच विचार के तब पूछिए।
So one clarification, the lipid circulation slides that you showed us, the images, those cells are not grown in sludge, right? They are the ones which are grown in sludge.
They are grown in glycerol.
Yes, purified glycerol.
Oh no.
Crude glycerol. The crude glycerol would still have some blackish color, brownish color.
वो सब भाग जाता है during your fermentation चला जाएगा, issues हो जाएगा, and then okay, during the breakage and आपकी separation when you fail separate नीचे बढ़ जाता है solids के साथ.
Sir, most of the country they are blending the biodiesel with conventional diesel, or they were using
petroleum
pure.
diesel, not 20%, just like us. Everybody, you cannot use pure diesel, pure biodiesel. Okay. You have to mix it. Petrol diesel, 15-20%, same chain as it.
And what is the base solvent of that biodiesel, sir?
Why?
Base solvent of that biodiesel.
Base solvent.
Base solvent.
Base
In which
solvent of biodiesel. Mean what?
They were just extracting biodiesel and putting volume by volume in a.
Oh, okay, yeah, okay. Yeah, but they have the pure 100% biodiesel solution, and then they are blending it between 20%. They're mixing with the petrol diesel and filling into the tanks.
What he is asking that if suppose this you have the solid forms of the diesel, that evaporation, that after evaporation, then you have to dissolve it in the hexane.
Hexane or methanol something, or we have to put in conventional diesel or petrol diesel, or we are just
okay, that I cannot tell you exactly, but I can inform, I can get this information from my investor partner, what exactly they are doing.
Because when we report like that, weight by weight, we are extracting this much amount of fatty acid methyl ester from this much amount of sludge or bacterial biomass. So it will be in a solid form. So what they are doing, they are taking 10 gram of biodiesel and putting into 19 ml of conventional diesel, and they were just blending ratio is 1:10 or 10% or 20%.
Yeah, 1:10, 1:15.
Yeah.
So that's my
No, it's about 90-10, 85-15.
85-50, something like that. Yeah. They are just
probably I have to go back and ask them exactly they know, but from my best of my understanding, I think it is just like that. It is just mixed with biodiesel. Because normally they get from the oil, they get the pure biodiesel, right? There's no oil there, there is no solvent there. Everything is
evaporated.
Everything is separated. And then why they will put hexane? Because if they start putting hexane and solubilizing, and then they put into the petrol diesel. Hexane is expensive.
So that's
of course not that expensive, but certainly it will increase the price of the biodiesel.
price. Of course, and
that,
when
And then hexane, it doesn't burn at the same.
it's also burned.
No, it burns, but it doesn't burn at the same tune.
And even density
Of course,
difference.
any organic solvent will evaporate and burn. But it should, what is the calorific value and how much they're putting. Oh, I have to go back. No, I have to go back. Good question. I never thought of it. But I
The
can.
biodiesel you produce, it's through sludge. I mean, this petrodiesel extraction must be something recently you've adopted. But before that, the
Nobody
biodiesel.
adopted. I think I decided crazy idea came to take cargoes from over here. And then I asked Sharon to connect it and see. But it worked.
Before that, the biodiesel you got was in solid form, right? Or from sludge?
No, it has always been in solution. Why it would be in solid form? The biodiesel you get, but you extract in some, otherwise, okay,
Yeah.
if you are not using this petrodiesel, then you have to extract it out. For phase separation, it has to go to some phase with some solvent. Alone it will not go.
Exactly. So
Alone it will not go to phase. It will be mixed with the
Some solvent.
with everything, with everything in the solution. Because this is a technique. Now you add chloroform methanol to separate it because the chloroform separate the phase. You get it, phase. Because you need a medium to separate. Biodiesel by itself has no characteristic to separate. Good question. I like this question which I cannot answer. You better go back and find out. चलिए मदन लाल जी, now this time I will not say any longer. I'm sorry, excuse me for that. चलिए, notice the silent spectators. मैंने कहा ना किसी को पूछो हिंदी, अंग्रेजी, संस्कृत, फ्रेंच, थोड़ी सी कन्नड़ भी आती है मुझे, उसमें पूछ सकते हो कन्नड़.
So, how do you maintain your CN ratio 144 throughout the fermentation?
Not in this case. This is
In
bypass.
yeah. How
Well,
do you-
so, you add okay, you have the slash. You remember how I told you how the process is conducted?
Yes.
No? You remember? Yes.
Yes.
So you have the sludge in the fermenter, you fill it up, okay, screen out everything, the vibrating screens, and then fill it in the fermenter, and then add 1 gram per liter of sodium acetate, and put the pump, actuate the pump, actuate the control system. So microbe will start growing, pH will go up slowly, you will dump the acetic acid. Okay? And then you add, because this nitrogen carbon ratio is with the added substrate. The added substrate is acetic acid. So you calculate how much ammonium sulfate or urea you require and dissolve in your acetic acid solution.
Dissolve in acid.
So when it is pumping, you giving a drop into that, so everything is coming together. So this is a standard technique in fermentation technology where extra nitrogen is required, especially in PCPA, ammonia, especially in PCPA, because you require a lot of nitrogen there for this to grow, and that's the standard technique to in effect batch process. You always solubilize ammonium hydroxide in the substrate effect. Otherwise, your system will be devoid of nitrogen and it will stop growing. And then your residual carbon will accumulate in the fermentation.
So the solution will pump in based on the increase in pH. That's
नहीं वो तो है ना
or there's some probe. That's what I want to ask.
The probe is there, of course.
For not for the pH, for this CN.
You just measure how much your volume is there. You saw that, okay, I showed you that it's right? So then you see, or you can have it, okay. In pilot plant we have a balance. Balance. So you put that 20 liter or 30 liter tank on the balance. And then that balance is continuously being ready.
How much is
How much is gone? Decrease the weight. Because there you use it in very high quantity. So I think in pilot plant I think it's 40 to 60 liters. So started with lemon. So that can make a difference on the. Now the balance is quite accurate, so probably plus minus 2 grams. So the electrical balance. And even the pump, it drops. because the pump flows, the pump speed is not very high, then it will drop the drop, pH will decrease a little bit. By the time the pump is actuated again, it goes up. The reaction is so fast in a big reactor, reactor, that the pump sometimes is unable to cope with the situation. So we have to increase the speed of the pump. That's why I said don't sleep. When you start it, don't sleep. Eat just another little method, or if you want to sleep.
So you must have optimized this CN ratio 144 at the fermenter level, right?
Yeah,
Not at the
everything.
shape level.
No, but initially, yeah, we just conducted a shape class to have a good idea that where lies the optimum, okay, approximately, and then we go. Let's say we have a hump, okay, so called the inverted flap, and then you go in that hump domain, and there take 3-4 points, and then do the 3-4 fermentation. You cannot do a 20 fermentation, because if you start keeping that way, then you take it for life. Or you use this type of method, that design method, which Shravan used in this one. Response surface methodology. Okay. There are the built-in programs. I'm already sure you must be having this program in your department. And issues. You can optimize medium shape class, and then we take that optimize, repeat it in shape class once again, probably at that level in 1 meter class. I have shaker which is for 5 meters class. They can have 1 meter medium, and then when everything is done authentically, then you go to the fermenter. Because fermenter is not required. Shape class is fine. You can do one shape and fill it up and keep it release. No spill, no foam, no vegetation problem, no radiation problem. So it's quite easy.
Everything is
Yeah?
isolated.
Yeah, right. And you can do that. That's why they always want to go for that. Right? They are in fact some. Those who do not understand the technology, they always try to stay on shape class. It's easy. Have lots of data, have application, have the paper, PhD. Okay. but those who know it. So I don't have those type of people. But certainly that's the way. You have to go step by step.
Professor Tyagi, I'm asking a general question.
Okay.
Maybe it's a repetition type. Everybody is talking about the bioethanol nowadays.
Bioethanol, yes.
Yeah.
People are
And
talking.
you have the wide experience of
Since ages, yeah.
bioethanol.
Bioethanol.
Yeah.
Yeah.
And why? Where do you have? Where do you think that the more prospect and more opportunities bioethanol or biodiesel?
Okay.
Because we have the exposure of both the two this area that we have.
I think I will give you example. Let me see if I have this much there. Let me take out okay, give me a moment please. Let me go to my students file. Somewhere should be his thesis. This thesis. Do you see anywhere?
This is it last year.
There should be some. Okay, there is no word file. I'm not looking for his word file. There is no word file. Okay, let me see. Anyway, so I'll tell you exactly what is the reason why we prefer. This last thesis is not on the introduction. This is the specific growth rate. Okay. Now so this is the specific growth rate in the washed sludge, and this one is in the centrifuge sludge. Correct. Now the specific growth rate value is something like maximum is 1.1. Correct. So these are the biodiesel using yeast. So because this is yeast, so it's a specific growth rate to the tune of the same as the yeast which is producing ethanol. However, let's see the specific production rate. This is also specific growth rate. So So this is the lipid production rate. You see here. Now this is the specific lipid production rate. Now what is specific lipid production rate? Is the per unit weight of cell, because that's the absolute term. Now when you compare this value, now this value is 0.4, 0.5. Blue one, the wash plus at 25 grams per liter, 40 grams per liter of glycerol, and the light green one is the centrifuge stress, okay, which is roughly 0.4. Now that is the goal. The specific production rate for yeast is 3 times this. 1.5, 1.8. 1.2 is very common. 1.2 is very, very common. Now this is the per unit weight of cells. Now this 0.5, if you multiply, let's say 40 grams per liter, the cell concentration in my reactor, so I have 20 grams per liter per day, correct? I will have the production 0.5, correct? So it's only 20. With there is 1.5. So 40 multiplied by 1.5, 60. So that is the difference. Number one, this production rate is very low. Very, very low. 3 times lower than the ethanol by yeast. And then the yield. You see, again, the yield factor, that is tons of biodiesel produced per ton of sugar. It is how much? 0.3, 0.2. Whereas in case of ethanol, it's 0.5. So there you produce 500 kilograms of ethanol per ton of sugar, glucose, let's say. And here is only maximum 300 kilograms of biodiesel per ton of glucose. So these are the reasons that the ethanol is cheaper, much cheaper. So why it is that? Because ethanol is extracellular product, and this is intracellular product, and intracellular products are always different. That's why in ethanol you don't need to look for a cheaper source. Even glucose is cheaper, and it will give you the economic value, but not in biodiesel, because lots of the carbon goes for something else. The cells only cellulose, what is good? Probably methanized, probably synthesized in one biomass. So basically, and the same thing, when you want to increase the reaction rate, now what do you do? This will increase the capital cost. Capital cost as well as the recovery cost, both. And then, on top of that, ethanol is very easy to do by distillation. Conventional processing can do it. You don't need to go for solvent, this, that, separate, and go into phase separation. It's simple. Just okay, you look at this question column. Multi-stage distillation column. But nowadays, very efficient distillation column are available, like the double cap columns. They give almost 98% renewable efficiency.
Sometimes ethanol and this water,
azeotrope mixture. Yeah.
How to separate?
Yeah, that is where you have to add the third compound, and that gets the azeotropic mixture, and then you get the absolute compound. That's how they do it.
Okay.
No, that's again a standard technology.
What is the third compound?
Oh, they can use some kind of cetane, hexane, sometime. I don't remember exactly, but what they use. Okay, I can dig it up for you. Because they have been using, in making absolute alcohol, because this business of power alcohol, so-called fuel alcohol came much up later. People were producing absolute alcohol to drink, and then people don't want to produce one. They want to produce to sell as a drink. But this is a government who are giving subsidies, and then fine, go ahead.
So you suggest that Madan should go for ethanol production also, because he has a bacteria which are doing the living valorization, living degradation.
Sorry, what is doing?
मदन
बताइए ना क्या बात है, आप तो ऐसे एकदम पीछे क्या बात है भाई, इतने शर्मा क्यों रहे हैं? हम भी आप ही की तरह भैया, ऐसे क्या बात है? फर्क इतना ही है कि हम आपसे इसमें बड़ा यहाँ खड़े हैं, वहाँ बैठे हैं, कल आप यहाँ बैठे खड़े हैं। चलिए बताइए तो।
एक्चुअली मैं लिग्निन डिग्रेडेशन पे वर्क कर रहा हूँ सर, मतलब बैक्टीरियल मीडिएटेड लिग्निन डिग्रेडेशन, एंड समहाउ to convert a lignin containing streams such as pulp and paper mill effluent type of things into value added products such as PHA.
And I want to use inhibitory compounds.
So question है आपका?
क्वेश्चन तो सर सर बोल रहे थे कि इथेनॉल पे सर,
So if you can remove the lignin, which is inhibitory compounds, so maybe you can get the more glucose and production, and then you can go for the fermentation process and then ethanol production.
Yeah, देखो चीज बात है, what is the problem in this process? Problem है, okay, number one, the bottleneck is to separate the lignin. That's number one, on top of everything. And that takes, to remove that takes a lot of energy, and I've got lots of energy balance on that. So, number one, if you are able to take out that lignin, then comes, okay, now you have cellulose, what percent, 100%, 70%, 80%, whatever is that. Then comes the hydrolysis. Right. Now, how do you hydrolysis? You do the enzyme hydrolysis. An enzyme, of course, is a cost of business, but you can do that. And then it's a feedback inhibition process. Because you go to, I think, I don't remember exactly, but probably 20 grams per liter it starts inhibiting, and by 50 grams per liter, everything stops. Correct? So that's another issue. And people have done on the continuous separation, like even my supervisor, Prof. Tyagi, did in the US Army Nautic Laboratory, that those experiments probably in 60s, 50s, I don't remember. And at that time he used a membrane reactor, and that was a very challenging work. So you can do still that technology, because nowadays membrane technology has improved a lot since 1960s, and you can use that and continuously separate. And or you can continuously, inoculate a microorganism which can grow at that temperature, because you have 50 degrees centigrade. So the saccharification temperature, am I right? And then probably you can decrease to 40, 45 degrees. Probably there are some yeast which can grow. Of course, Saccharomyces cerevisiae can grow, which is the mostly used for the production of ethanol. And I had this project with PKRC. I was talking. That's what he was doing exactly. The simultaneous saccharification of fermentation, and if I remember, that name of the yeast was Pichiachelsky. And then, if I remember those results, it was also producing probably at around 10, 20, 20 grams per liter. Because somehow, I don't remember exactly what was the cause, but you can dig up into the literature, you can find it easily. And, but yeah, so basically that is the problem. See, that is the problem. And you can do that, and I want to show you a graph if I can go to that. If I can go to that, I have to see where is that graph. So let's see. Go to my computer. So Tyagi. This curve I normally teach in my course of environmental biotechnology. And if I can get hold of that, you see here that now diagnostics, pesticides. This one. You want to find out something else, and it's going to be closed. Hydrogen. I want to show you that because this steam consumption versus anyway, I'm not getting that. Anyway, so I don't know where it is. I cannot locate it. I should have it here. Anyway, okay. Okay. Now the. Basically, when you separate ethanol in a distillation column, the steam consumption goes like this. Okay? Basically, here is the percent ethanol. in broth, V by V. So basically it goes 1, 2, 3, 4, 5, 6, 7. Correct. This is the pound of steam consumed per pound of ethanol produced. Correct. So if you have this, let's say 1% mean about roughly 1, 2, 3, 4, 5, 6, 7. Correct. So let's say if you have 10 grams per liter, how much you will get ethanol? 10 grams per liter means 20 grams per liter sugar roughly. Let's say 20 or 30 grams per liter sugar. So you'll have 60 grams, 30 grams per liter ethanol, so 60 grams per liter sugar. And then where are you? You are here. Correct. Whereas in normal fermentation process, okay, let's say if you have glucose or starch, you have a minimum of 7%. People are talking nowadays up to 10%. Okay, so basically here is the difference. It's not only your, okay, number one, your enzyme level, and you are using all those things, but here this difference makes the process completely impossible. Okay, in this case, number one, with 3, you have used enzyme. You have used high temperature to solidify. Then you have got a little bit of sugar, and that little bit of sugar then you ferment, and having the same fermentation operation, and then you produce this very low quantity of ethanol, and then you consume a horrendous amount of steam in distillation. So all these factors put together, they put you out of business. You are nowhere near doing this. And this is very important. This is the most important. That's why all the time people say, I want to have high ethanol concentration. Right? Even you use molasses. Okay, people use molasses. Molasses is 50% sugar. Correct, almost. I don't know why sugar in Indian molasses is high. I was in Ivory Coast. There was a French company who was producing sugar from sugarcane, and they were having only 40% of sugar producing sugar in their molasses. So I'm not sure why, what type of technology they're using. Most of the mills in Uttar Pradesh, western Uttar Pradesh, is not very far from that. So they have all 50% molasses, right? So you simply dilute it to 20%. And of course viscosity will be quite high in the 20%, but you have a lot of osmophilic yeast. They give you some 10% very easily. I mean, just like that. Just like that. And I don't know if you have ever seen a distillery operation, any one of you? So you go there, they are the open tanks, okay, the round shape, okay, cylindrical, and you have a big crust deposited everywhere inside the fermenter. I don't think so they ever clean that, and they complete the process. They fill molasses in this, add some inoculum, and this I think within 1 or 2 hours it start boiling because of this CO2 production. And then ethanol comes develops so fast that it doesn't let go anything. So basically, this process is so simple, and then it reaches a steady state around 48 hours, and they just simply pump out this the broth, and they settle the yeast, and they have this liquid and pump it to the distillation column. So the process is so easy. I mean, it's unbelievable. I mean, there is no science. Whatever science is there, they don't apply it because these are run by our lalas of UP, and they just don't care. So these are the bottom line. You see, that's why I have the strong, notions that, of course, having said that, okay, don't take me otherwise, because research is the research. I always do it. Okay, one day, who knows? From tomorrow onwards, you may have breakthrough. Who knows? You may develop some idea. But given present scenario, because problem is not one. It's a multi-problem problem. It's a multi-problems problem.
Okay, Raj,
yes, sir.
what you have done there in IOCL?
सर मेरा काम माइक्रोबियल फ्यूल सेल्स पे था, तो माइक्रोबियल फ्यूल सेल्स पे वेस्ट वाटर
Have you
ट्रीटमेंट.
done any use this glucose for the microbial fuel cells for the electric service? Glucose? Have you used it? No?
सर मेरा पेट्रोलियम रिफाइनरी वेस्ट वाटर था तो
This is, because I was a very good area of research. Because so many people are working for so long, so much of knowledge has been amassed,
Yeah, still the people are getting
and there's so much of missing.
Yeah.
Whatever we know only tip of the iceberg. We know only tip of the iceberg. Because as I said, this is nature, which has created it, and people don't against nature. Probably one day, the mankind will succeed in making this complex. But on the same, on this note, what we don't forget that the pyrolysis technology does work. Okay, you heat it under in vacuum or in the absence of air, not in vacuum, at high pressure and temperature, and then evaporate, and all the volatiles go. It does the volatile, they are fermentable, and that fermentable substances are available. There are companies, even in India also. A guy, I forgot his name, in Chennai, this company, and I happened to meet him a couple of years ago when I came with the Canadian Consortium for the cooperation program with Indian scientists. So we were here in what is that organization? Engineers, something like that. So we had a meeting, a big seminar with the Indian industrialist and that organization, engineer something, I don't know. But we had a big discussion for 3 days here, and then we had a very big discussion in Bangalore. Okay. And so there may be some big comment, But I'm not sure. Research is research. It always means greed. And sometimes when you do research, you discover something else. That's how they discovered that Teflon tape was discovered. The chemist left over the night, he was doing something else, or she was doing something else, and left overnight some solution. She got in the morning, and surprisingly, she got something positive. And then they analyzed it was nothing but the Teflon tape. Now, and after that, the tritium was converted into Teflon tape, which is used worldwide.
So you say something about how you can use it, or this work and all these things.
Sir, I have heard from this.
Thankfully, it's now, yeah.
Canada water is so abundant, so I'm sure you don't need to value the amount of water you use for washing the sludge and everything like that. Have you done some kind of a water audit? Because here it's a very precious commodity.
Water.
Water. We just use water to wash the sludge and discard that.
No, but you have to reclaim that water. It goes back to the wastewater.
Do you do that? Do you reclaim it?
No, we do not reclaim that water. We just simply dump it in the submerged. What is the ways we can nowadays? That's what we call the zero discharge. People are developing the technology, zero discharge. So and it's not that okay. In Canada also, some industries are following this zero discharge. Like pulp and paper industries, they just consist of water. You can't imagine how much water they use. Any pulp and paper in Canada, any pulp and paper unit will be on a bank of a certain river where they pump their water. Of course, they have some underground water, but that's not enough. The quantity of water is something else, and they have zero discharge. Many plants they are showing that because it's called incentives in the government. You have to show even if we have a lot of water, no problem. It should be they show zero discharge. They treat it well, they recycle it. I know a ethanol producing unit in Saskatchewan, and by the way, I know the president of the company is also an Indian. By the way, it's Tyagi also, and I talked to him, and they have also zero discharge in the ethanol making business. So they make ethanol. They have the stillates. They recycle the stillates for the animal feed, and whatever the water is comes, they purify, and then they feed back to dissolve that when they grind the wheat. So basically, this zero discharge.
You want to ask any question? Huh? Class, before going to class, you have to ask one question. Huh?
lecture question
I think that if you don't have any question, then today's session is over. Okay? So, तुम लोग बताओ, you want to say something, you want to ask me question?
प्लास्टिक टू
प्लास्टिक की बोतल होती है सर, उसमें लिखा होता है कि इसको यूज़ करने के बाद इसे प्रेस करके फेंक देते हैं। तो इसको जब हम कंप्लीटली स्टडी करते हैं इसकी और बायोप्लास्टिक जो होते हैं, तो उसमें ऐसा क्या होता है कि सर मतलब ये कुछ बाद में टॉक्सिक सब्सटेंस रिलीज करता है अगर इसे यूज़ करते हैं। जैसे सर
ठीक कह रहे हैं या
मैं ये कहना चाहता हूँ कि इसको क्यों यूज़ करते हैं, इसको क्यों नहीं यूज़ कर सकते हैं बाद में?
बोले दोबारा से क्यों नहीं यूज कर सकते?
हाँ सर, जैसे किसी भी बोतल में देखिए।
नहीं नहीं, नॉर्मली क्या होता है, अब ये तो ठीक है ना, ये प्लास्टिक की बोतल है, ठीक है। लेकिन पहली बात तो यह है जो टॉक्सिक कंपाउंड होते हैं ना, इसमें वो प्लास्टिसाइजर जो मतलब शेप देने के लिए
Halides is the plasticide.
समझे, वो जो है वो फिलर्स होते हैं कि जो भी है, तो वो जो कंपाउंड है वो टॉक्सिक होते हैं, ठीक है। और आप इसको क्यों नहीं यूज करना चाहते, तो उसके बेस होगी, अभी मुझे कह नहीं सकता हूँ क्यों, क्योंकि वो लीच आउट होने का डर होता है, ठीक है। तो वो लीच आउट हो सकता है वेरी इजीली, सो द लॉन्गर यू कीप द लॉन्गर प्रॉब्लम। लेकिन बायो प्लास्टिक्स में जो फिलर्स यूज किए जाते हैं, या जैसे इसमें बिस्फेनॉल यूज किया तो उसमें बिस्फेनॉल यूज नहीं करते, दैट्स द कंपाउंड वेयर इट कम्स फ्रॉम दैट। तो वो उसके अलग हैं, उसके वो नेचुरल फिलर्स हैं, उसके जो भी हैं तो प्लास्टिसाइजर्स होते हैं, वो उसको उसके नेचुरल है, जैसे सेलुलोज है, लैक्टोलोज है, उसका पॉलीमर है। तो वो अगर वो तो सब बायोडिग्रेडेबल है, नॉन टॉक्सिक है, तो कुछ उससे तो इसलिए इसको माइक्रोवेव में रखने से मना करते हैं। माइक्रोवेव में अगर से रख दोगे कोई प्लास्टिक तो वो लीच आउट हो जाएगा, जितने बार भी प्लास्टिसाइजर्स तो उन्हीं का खतरा है। बाकी तो प्लास्टिक थोड़ा ना निकल के आएगा इसमें से, पॉलिस्टाइन नहीं आया जो वो तो निकल के आएगा नहीं, वो तो स्टेबल कंपाउंड है, वो तो वैसे डिग्रेड नहीं होता, उसको डाल दो मिलियन ज़ीरो पड़ा रहेगा, वो कहीं भी डाल दो, उसकी तो प्रॉब्लम ही नहीं है। तो प्रॉब्लम वो जो जिससे बनाया गया मिला तो उसकी प्रॉब्लम। और फिर ये जो मटेरियल देखें ना, ये मटेरियल है, ये बड़ा वो फ्लेम्सी है और मतलब इस टाइप से बनाया गया है, वो स्ट्रॉन्ग प्लास्टिक वो तो है नहीं, आप इसको रीयूज कोई भी प्लास्टिक को रीयूज करने का मना करते हैं, कोई भी नॉट ओनली दिस। ये तो इसलिए बनाया गया कि मॉडल लैब यूज करके फेंक देंगे। और दूसरी बात ये इंडिया में ये भी नहीं तो इसको उड़ा के लोग पता चला भर के बाहर तो इसमें ये भी तो हो सकता है
यूज करते हैं सर इसको।
लोग
नहीं करना चाहिए,
यूज करते हैं,
नहीं करना चाहिए, नहीं करना चाहिए।
ये यूज करके फिर से वाटर यूज करते हैं, दैट इज व्हाई दे आर आस्किंग टू ब्रेक दिस। ओके सो
और गूगल पे पढ़िए इसके बारे में, सब पता लगता है, गूगल करके।
Okay, thank you very much for coming. And what you will do on 11th? Tell me. Are you going to present?
Exam.
Huh?
Exam.
No exam.
Exam is not a good
Not a
पढ़
good
के
language.
आके दे सकते हैं।
So, hey, why not you are presenting what you are doing? Okay. So I will ask some 4 or 5 people to work for the presentation. 10 minutes, 15 minutes presentation. ठीक है पूजा? So you may be one of them. Landfill agent. You have also done good work. So why not you are presenting on 11th for 10 minutes?